am not going to write out any of these theorems for you because it's writing things over and over that are pretty much saying the same thing just in a different order. So I'm going to draw you a picture of each different one. The things that I draw you in black are the things that we know, and then the things that I draw in red are the things that because we know this, then this is true, right? So basically the black is the hypothesis of the theorem, and the red is the conclusion, what we know because of the black drawing stuff, okay? So I'm going to draw you 3 different circles. Give me a second here. All right, so here's what the theorems, well, here's what the first theorem says. It says, in a circle, if a diameter is perpendicular to a chord. So if a diameter, here's our center, the diameter would go through center, is perpendicular to a chord. So then you have a chord. That's not a good one. Okay, if a diameter is perpendicular to a chord, so we know we are going through the center, we know we have a diameter, we know we have a 90-degree angle, okay? Then the conclusion says, then it bisects the chord and its arc. So if this is A, B, C, we'll call that point D, okay? If this is my setup, and it is perpendicular and it's a diameter, it is bisecting the chord and the arc. So the things we know from this is this piece of the chord is congruent to that. In other words, AD is congruent to DC. Okay, and the arc got bisected as well. So arc AB is congruent or is equal to arc BC. So arc AB is congruent to arc BC. Okay, so knowing the black stuff, therefore the red stuff is true. Okay, that's the first theorem. The second theorem says if the diameter bisects the chord and goes, if a segment, bisects the chord and goes through the center, then it's perpendicular. So for this one, we know we go through the center. In other words, we know we have a diameter. Okay? And then the chord and the arc are bisected. So we know this is true and this is true. Okay? So the black is given to us. Then we know that this has to be perpendicular. Okay, so the red is what we know because they told us the black stuff was true. So if we label it all again, A, B, C, and D, we would say that AC is perpendicular to BD because of the markings in black. Okay? So that's the second one. The third one says, if it's perpendicular and the chord is bisected, any guesses? What are we going to know for this one? If it is perpendicular and bisected, so this is perpendicular and these are congruent, then what should be true? Thoughts? Then it's a diameter, right? Then it's going through the center of the circle. So we know that we're going to give this a letter E over here. We know that BE is a diameter. Okay, it goes through the center of the circle if it's perpendicular and bisected. So as you can see, all very similar pictures. It's just which two pieces of information did we know to get to the third piece of information? Okay, questions on those? Okay, then I'm going to give you 4 problems involving these. Are you guys done with those pictures? Can I move on? Not quite. Okay, here's your first one. Let's say you have a circle. And this is the center. And this is perpendicular. Okay, I have X here, which is a radius. That's what we're looking for. This little piece is 5, and this chord is 12. Okay, so think about what we know in this picture. We know it's perpendicular. We know it goes through the center. So what is true? We are going to use the Pythagorean theorem because of this one, right? It goes through the center. It's perpendicular. Therefore, the chord is bisected. So that means that these two are the same. How long is that side? 6, right? If the whole thing is 12, then that's 6. And now you can use Pythagorean theorem. So you're going to do 5 squared plus 6 squared equals x squared. And then just solve for that x squared. So 5 squared plus 6 squared is 61 for your x squared. And then you're going to square root that. And then just round to the nearest tenth because square root of 61 is not a pretty number. So that comes out to 7.8. Okay, so you're going to see a lot of Pythagorean theorem in this lesson. A lot of Pythagorean theorem. Questions on that? So the chord was bisected, right? How about this one? We know this is the center of the circle, even though it doesn't look like it, sorry. Okay, so in this picture, we have 5s for our chord. We have a center of the circle. What can you do with that? Sorry, we're looking for this piece. I guess I should put an X there, huh? How can you find that it's not a radius, part of a radius? It's not 5.
Well, wouldn't it be, would you use the 9 somewhere?
We are going to use the 9.
Because it's almost the same.
What can you tell me? So of our 3 theorems, right?
Right.
What can you tell me is true from this picture? It goes through the center and it bisects the chord. Therefore, it goes through, goes through the center, bisects the chord. Therefore, it is what? Look at your pictures. What was the third thing? No, it goes through the center, which is essentially the point we were picking out with the diameter there. We know it's perpendicular, right? If it goes through the center of the circle and it bisects, then it's perpendicular. So if that's perpendicular, what do you know about radii in a circle? They're all the same. No matter where you put it, it's the same. Where do you have a radius? 9. Okay, so what if I move that 9 here? Still 9, right? And now you have a Pythagorean setup. It's not going to be a perfect triple, but you can use the Pythagorean theorem, okay? So you're going to do x squared plus what? 5 squared equals 9 squared. So simplify that. X squared, take away the 5 squared from both, which is not 4 squared, right? 9 squared, so 81 minus 25. you get x squared equals 56. And then you just square root both of those and round to the nearest tenth. So x is approximately 7.5. Okay, questions on that? Okay, so look for radii that are in different places. Look for the random one that.
Which one did you use?
Which, it was this one,
Okay.
right? We knew it was bisected. We knew the chord was bisected, so we knew this was true.
Yeah.
And we knew it was going through the center, therefore, we know it's a right angle. Okay? All right, how about this one? Oh, sorry, I wasn't ready to draw my circle yet. We're moving up. Okay, in this one, we have, that is not the middle of the circle. Rewind. Let's start with trying to find a center. All right, so right now x is AB, the whole thing. Okay, so I want to know the length of that chord. What do I know from the theorems right now? I have the center. We're going through the center here, right? I have a 90-degree angle. So if you're going through the center and you have that 90-degree angle, what's true? The chord is what? We know it's perpendicular because we have the little square, right? What's happening to that chord? It's bisected, right? So I know that these are congruent, which means if I'm trying to find x, the whole thing, if I just find the one, I can just double it to get my x, right? How do I find the one side? Pythagorean theorem. Are you seeing a trend here? A whole lot of Pythagorean theorem. Okay, now here's where you have to be careful on this one. Technically, that's not x, right? It's half of x. But what I've seen in the past is when people try to call it 1/2 x and do the Pythagorean theorem, they do the Pythagorean theorem wrong. So if I were you, when I do a problem like this, I would just give this a different variable for that little piece. Call it y for now, okay? You can do 1/2 x, but then you have to square the 1/2 too, which becomes 1/4, and it just doesn't go well. So if I were you, give it a different variable and solve it that way. So this would be 4 squared plus y squared equals 6.8 squared. And then you simplify that. So you get 6.8 squared minus 4 squared. So y squared equals 30.24. And then you're going to square root that. And you get about 5.499. Okay. So that's your y, but we want x. We want the whole chord. So you're just going to double that. So go times 2, and you get to the nearest tenth. It comes out to this, 10.998. What is that to the nearest tenth?
11.
It's not 11. To the nearest tenth. Where's the tenths place? One more after the decimal point, right? So is it 11 to the 10th? 11.0, right? And everyone's like, that's lame. Why do I have to put a 0 there? I'm telling you why you have to put a 0 there. If they want it to the nearest tenth, they're saying this is how specific we need it. So if you say it's 11, that could be 11.1, 11.2, 11.3, 11.4, right? If you're rounding, 11.4 if you round to the nearest whole number, is 11, right? But if they want it to the nearest tenth, they're saying we want to be more specific than that. You have to round it to 11.0 because we know it's not 11.1 or 11.2 or 11.3. So I know it seems ridiculous. Every year I have an uproar that you have to put a 0 there. But it is for a purpose, I promise. It's much more specific than 11. So just put it in there. Questions on that one? All right, last one. You have $15 here, 11, and 11. Okay, so think about what we know. You have a center of the circle, and these are congruent. Therefore, what is true? We know it's bisected. We know it's the center. It has to be what? Perpendicular. Okay, so we know, based on this picture, that this is a right angle right here. Now, what do you do to find x? Move your radius, okay? So just like that second one that we did, just with a different reasoning behind it, you're going to move your radius to here, which is 15, and then it's going to be x squared plus 11 squared equals 15 squared. Okay, so Pythagorean theorem, and just be careful that you're putting your hypotenuse by itself. There's a lot of Pythagorean theorem here, so it gets easy to start putting things in the wrong place because you're doing it a lot. Just take your time. So 15 squared minus 11 squared. Oh, those are letters, not numbers. 15 squared minus 11 squared. So you get x squared equals 104, and then take the square root of that, which should be close to 10, right? If we round to the nearest tenth, square root of 104 comes out to 10.2. Okay. So look for triangles, look for the Pythagorean theorem. It's pretty much what you're doing today. Any questions?